I need to have trainings. This project has been on the books for at least 5 years now. All I do is I change the data in it, I change to new examples. And I think people are overthinking that when I hear that the tutors can't do a CT table. It's multiplication. You take 10,000 and multiply it by a percentage. I mean, it's not like I'm asking them to differentiate anything. So I'm thinking I hear this more and more. The trick is, I don't know, that's a positive test result, which means that you had an issue with the tutors at the testing center. Did anybody work with the tutors and have no issue whatsoever? Okay, couple. Who? I'm just curious, because I always hear about these. I hear about the ones where the tutors couldn't help, but I don't hear about the ones where the tutors could help.
Well, they were helpful, and it did take a lot more time than if I
Of course,
would
you're
have
sitting with
asked
somebody.
you or Carly or something like that. But
I drag you through it too.
eventually,
I would drag you through. It wouldn't be quick with me either. I would sit there making sure you understood what you were doing and why you were
right?
doing
He
it.
just kept coming up with we kept getting the wrong answer, and it was one where we already had the answer. So
Right,
it was like that.
which is why I put it
was,
there to make sure
yeah,
you know you're shooting
over
the right.
and over.
Did it end up being something amazingly simple at the end of the day? Yeah, and that's always the case. That's why I think the tutors want to make things harder than they actually are. I love you guys, I do. But I think they want to make things harder than they actually are. That's multiplication and addition. I mean, the whole point of that is I've spent 15 to 17 years of my life trying to figure out the best possible way of getting this very important idea across to students. And that's the best way I found yet. You saw the other ways, the formula. You don't want to do, well, you do want to do that. It's actually, you were doing the formula, believe it or not. If you think about what you were calculating in those tables, you were doing that formula. I just made it have a sample space of 10,000. What if you made a sample space of 100,000? Would it change anything?
No.
Not at all. It's a ratio. It's the same ratio. 10% of 10,000 is the same percentage as 10% of 100,000, as long as you apply it across the board. So I wonder, maybe I have to have a training with the tutors to find some more time in my day.
You gotta make sure you do
I don't
the
sleep. I don't sleep 8 hours a day, right? 6 is good.
6-4. No.
4 is even better.
No, we
I can
should
tutor
do
more
8
people.
actually.
Maybe go
5.
You gotta make sure you do the math, the other math though too. You can't just do the, like, you have to do the subtraction.
Oh God, yeah, or the addition, depending on how you look at it.
Yeah.
Yeah, you have. I mean, it's a combined. I got an email from a student, not in this class, about this project too, and the email said it would have been easier if the ones you had us do at the end were like the ones in the examples. And I was like, wait a minute.
They were exactly the same.
And then I read further. I was like, what does this student mean by this? And the statement was the examples. Yours were full of percentages and the examples weren't. And I want to email back and find out what the full of percentages means. There are only 3 percentages in every single problem. There's the rate of infection of whatever you're studying in the population, and then the false positive and false negative rates. That's it. Just like for every single example before it. You know, like there's a chance of mercury in the fish. There's a false positive and false negative rate. There's a chance of Down syndrome in a fetus, and there's the false positive and false negative rate. Every single one of them has 3 percentages.
Yeah, but you tricked us with the whole sensitivity and what's the other?
How is that a trick? I defined it for you.
I know.
Is the dictionary tricky too?
No, I didn't have a problem with it, but you had to do the backwards math too. So on one of those, so you had to so it was like 94%. Then you had to take 6% or something like that for the false positives, or just to make the numbers perfect.
The complementary.
Yeah, the complementary stuff.
How's that tricky?
I'm just saying.
I know what you're saying. I'm trying to
problem
understand
with it. I didn't have a problem.
I'm just saying, it's tricky.
Because
Okay.
you use different words.
Well, and they're not my words, they're the words that exist in industry. That's why I finished it with, by the way, this is commonly used, let's make sure we understand it if we see it.
But in the first, I'm thinking from that guy's point of view, from the first example, you never used those sensitivity in that other one. At the beginning, the first 2 examples you didn't
Here's
use
why. When I'm showing Max how to ride a bike when he's 2 years old, I don't put him on a 2-wheeled bike with a gear shifter, with hand brakes, and pushing on the road and say, good luck, kid. Piece by piece by piece by piece. Which is, hopefully you've realized that's exactly the same way we learned everything in this class too, piece by piece by piece by piece. That was the last piece of the puzzle at the very end. Which makes it also fresh in your mind when you read the next problem, which involves those terms.
I understand that.
Okay, good.
Looking at it from that guy's point of view.
Oh, that's what I want to email back and find out if that's what was going on. I don't know.
If you use those 2 words in example 3 instead of example 4, does that make sense?
That's like putting them on the bike at 4 instead of 3 instead of 5. I mean, you gotta realize how much time I spend thinking about this stuff.
I know.
It's ludicrous, and I'm not sure. I want to know what full of percentages means. I want to know what that phrase means, because I mean, good lord, it's a probability class. It's full of percentages. That's all we have in this class. So I want to know what that,
But
it could also be, since the email came in at midnight last night, that there's maybe some bias in the sample.
Or that, and like maybe there's like thinking about the turning the percentages in decimals, which I do. It's just easier for me to use, you know. Boom, done.
But you didn't.
Well, you have to. I mean, you can't do it with the percentages. You have to change it to a decimal to use it. And, which is why I learned that about 2 years ago to start giving you guys the decimal equivalents in the problems. Because what was it, 0.207%, that was screwing up students left and right. They were calling it 20.7%. I'm like, holy crap, that's 1 in 5 people have Lyme disease. Like, it's not that prevalent. Even on the East Coast, even in Lyme, Connecticut, it's not that prevalent. So that's why I started putting, by the way, this is 0.00207, because students were having a hell of a time with that. And that brings up a very good question that the reason I'm late today, sorry, this is a great segue actually. Doug Nelson, you guys may have had him in a previous class at some point, maybe you did. Doug, he was standing outside his office and I heard him take this big deep breath like, ugh. And I'm like, what's up, dude? This was like 8:05. He was looking at Math 95 stuff. And he was looking at what is in the Math 95 curriculum, and he was intensely concerned about this notation of f of x is greater than 0. And I was like, I know that the students have a hard time with that. Totally know that they have a hard time with that. And we started talking about why students have a hard time with a statement like, you know, f of x equals 0, which I know you guys have seen. Need that much marker. F of x is greater than 0. What does that mean? If you had to sum that up in, I know this is 243, apologies for the last day of class. Function of x greater than 0, what does it mean? If you had to explain that to somebody in English.
Frequency of the average.
Positive.
Say that again, Marty.
The frequency of the average is greater.
Oh, damn, I got you all brainwashed now for statistics. Good for you, sister. Ah! You have to think back to your algebra days. If you don't want to, just take a nap for the next 30 seconds while we talk about this. If you had to explain that to somebody, like you're out in your front, I told you this before, right? You're in your front yard, you're cutting your lawn, the guy next to you is cutting your lawn, you have a very quiet lawn while you're talking to each other. And your neighbor asks you what this is. Now, this is never a question we have in this class because we talk about things like averages and probabilities. So if you were to explain this to them because they were complaining because they can't help their kids with their homework at night, how would you make someone make sense of that statement, f of x is greater than 0?
Tell them to Google it.
Tell
Whoa,
It represents a function.
Okay, so what is a function?
A process of.
Oh! Oh, that's gorgeous. That's a wonderful way of describing a function. A process on what to what? What does it do?
It
Oh.
makes an answer.
Good, good. And Guy, what you're saying is perfect. You're describing a function perfectly. Can you give me an example of a function?
X plus 1.
Good. What is it? What is the point? What is x plus? So f of x equals x plus 1. That's the function. That's the process. What goes into the process?
Anything greater than 0.
Oh, good. Now forget this for a second. X plus 1, right? F of x is x plus 1. What goes into that?
Numbers.
Numbers. And what variable is the input? This is the problem. That according to the traditional algebraic curriculum, should be automatic. X goes in, what comes out?
Y.
Y.
Where's Y?
Plus 1.
Where's Y?
F of x is y.
Boom! That is Y. F of x is simply a Y value. It's the end of the process. An input goes in, an output comes out. You guys have been using these all terms, I just haven't been calling them this all term. Whenever you guys run dist fill, all those L2 values that come out are f of x's. They're outputs for an input of x equals 0 or 1 or 2 or 3 or 4. I haven't been calling them functions because you see what's happening? That paralyzes students as soon as it gets symbolic. So what is this really saying? F of x is greater than 0. That means that y is bigger than 0. You've got outputs that are positive. That's all that's saying, but it paralyzes students. So the reason I was late was we were trying to figure out ways of deconstructing it. And the reason I'm really late is because not because of that or because of that, it's because of this. This kills students too. This absolutely murders students. I'm so thankful so often in this class that we don't deal with negative numbers hardly ever. Every once in a while we do, right? But you guys get them immediately. When was the last time we talked about negative numbers?
6 weeks ago.
6 weeks ago, actually, like yesterday. When we talk about the z-scores on the standard normal curve. But you don't even think about it as negative numbers because you think of it as below average. You've already got a context with it. If the z-score is negative, you're below average. It's already contextual to you. Boom. 6 weeks ago-ish, call it 3, we were doing the expected values of gambling, of Vegas games, which were all negative. And why were the Vegas games expectations all negative?
Losing money.
Because you're losing money to them because you have to, because they have to make money to keep themselves in business. So as soon as you can apply a context to it, it becomes you're not struggling through. This is like trying to read a book but never be able to get past the cover.
Yeah.
You guys are in the book the entire class, right? You never had to crack a cover because the cover was like a paperback, like a well-worn paperback. Chapter 3 is where I want to be right now. So there is a humongous challenge mathematically, pedagogically. But the problem with this too is it's inherently tied to calculus, which is a beautiful thing, but unnecessary for so many people. So anyway, that's why I have to stay up and get less sleep every freaking day because I'm always thinking about stuff like that. The best way for you guys to learn something, which comes back to this project. That's the reason this project looks like it does. So when I hear the little comments like there's too many percentages, I want to know what that means. Because if one student has that thought, maybe somebody else does too. And if I can fix that and not lose anybody else, I've at least picked up one more person for understanding. So this is why I constantly, you look at my floor in my office right now, it's covered with papers because I'm looking at all these results. All right, enough of that jibber jabber. Let's get back to what we were doing last time. Let's wrap this thing up. We left it in an interesting place last time. We were rolling dice. Actually, you guys were rolling dice.